For the second part of this mini-series, I have invited Simon Schmid from the Graph to join me for a coding session. During the call, he will guide us through both the theory and practice of creating a subgraph, as well as explain the new feature, file data sources. Let's jump on the call. Hi Simon, thank you so much for joining this coding session. It's gonna be great. To start, what if you share with us what's the graph and what are the pain points it solves?
Hi, Nestor. Thank you so much for the invitation. Yeah, my name is Simon. I'm working on the graph, and the graph for me is kind of the missing piece in Web3. It's the data layer of Web3. So if you're building a app like you already started, right, Nestor, then you have a contract that stores. You can think about it's the business logic that you have on the blockchain, and it's there and it's very secure. And on the other hand side, front end for the users as a user interface that makes it easy for people to interact with that smart contract. But more often than not, you also want to display a lot of data that happened in that smart contract. So when you think about an NFT, for example, you want to have it on the website that people can browse through this NFT, see which traits which NFT has, maybe even having some aggregation on that NFT. So which NFT or which trait is how rare and how do they look? And if you want to get that data out from the smart contract directly, you end up repeating JSON RPC calls that can take up to minutes actually to load just a simple site that displays some NFTs. The graph now sits in between and pre-processes this for us. We can write a subgraph that lists two events of a smart contract and stores according to these events stuff in the database in a schema that we can design. And with that database that runs in indexes in a decentralized network of more than 600 indexers, we have a decentralized GraphQL API to quickly query that data. So instead of loading from a front end directly through JSON RPC, a list of NFTs that can take up to minutes, we can have like one GraphQL query, goes to the decentralized graph network and just resolves quickly with one of those indexers. So we have like the user experience, how people are used to the web and mobile currently.
Thanks for that detailed explanation. What if we jump right into the code and show you what we have for you to walk us from there? Sounds good?
Yes, please, let's do that.
Let's start. We have already a mono repo with two packages. On one, we have the NFT smart contract called Celo. It is verified, and also we have created one subgraph on Subgraph Studio. From here, what should we do next?
Yeah, that code looks exactly very good, especially the mint event, which usually is not emitted in NFT contracts, helps a lot for the subgraph, but we will see that later on. Yeah, this on line 30. Yeah, so the next step, as you said, we log into the Subgraph Studio. You already did that and create the subgraph. In the wizard in the studio, there will be the choice for which chain to use, and Celo Alfajores is one of them. And we are already there. Log in with any wallet and we can go. So we can start the subgraph. So maybe you want to just copy that command. There will be a setup wizard that helps us creating a subgraph. First question is which protocol? The graph supports several protocols, as we can see, Arweave, Ethereum, Near, Cosmos. Since Celo is EVM compatible, we can go with Ethereum here. Subgraph slug, we already defined through the command line, so we can just take that suggestion. The directory here, you want to probably change to subgraph, since we are in a monorepo. And in that list, we need to scroll a little bit down. There are a lot of EVM compatible chains, and one of them is Celo Alfajores. And now you can copy paste the contract address over from the block explorer. All right, don't despair when we see that error. It tries to download the API from Celoscan, but sometimes this doesn't work. It's an easy workaround. We just need to have a path to the API. Open hardhat folder, and where is it? Artifacts, and then contracts, and then Celobox JSON, right click and copy the path. So that was not a problem. In order to get the start block, we can go back to the block explorer. And when you see on the top right, the contract creator add transaction, or yeah, you can also just get that transaction and copy paste the block over. Exactly. Cool. Then take the same name, it's Celobox. And here's where the magic happens. Now we can scaffold the subgraph according to all the events contract emits that automatically are stored in the database of the indexers. So let's do this. This is very cool. Nice. And it asks for another contract, but I think we're good. Perfect.
Yes.
Now, we don't exactly need to extend that subgraph, in my opinion. Let's have a look how it looks like if you just bare-bonely deploy it. So if you go back to Subgraph Studio and copy-paste this graph auth command.
Okay, this is for logging in Graph Studio, but what is Graph Studio?
Good question. Subgraph Studio is a service that's provided for you, but it runs on a centralized server in order to help you deploy to the decentralized network. Cool. We are already in Subgraph, so I think the next step would just be to follow what's in Subgraph Studio. Really blind, we can look into Subgraph later on. So I would just run graph codegen and graph build.
Just copy here.
Yes.
So we found two bugs here. First, couldn't locate Graph Protocol GraphTS library, and we solved it by adding this package as a dev dependency on the latest version. And then another one was about adding the version on the project's package.json. Remember, if you are creating a subgraph under a mono repo, you should update the version to sync with it.
We can go to Subgraph Studio and copy paste that command over.
Here.
And now it works. Boom. And go back to Subgraph Studio and just deploy it for now. Give a version number, probably the same as before, 1.00. You're free to put in whatever, but it's best practice to keep in sync with package.json. Or you need to just increase the number every time you deploy a new version of the subgraph. Cool. We have a subgraph deployed to the Subgraph Studio. Awesome. Let's check it out. On the top left, there is the Explorer pane. You can open this to start to explore the GraphQL schema. GraphQL is an amazing, fully typed language. And because of that, we can explore the schema without actually reading documentation. So just by looking at what we have here, we see that for every event that this contract emits, we see there are approvals, approval for alls, NFT mints, ownership transfers, and transfers. All of these have like one query that we can take a single one that we always need to specify an ID. And then there's the same thing with a S at the end. And there we don't need to specify an ID. That gives us a list. So if you close the transfer and just keep the transfers open, and then let's click on block number, block timestamp from ID to token ID. Let's have all of it. Let's see what that subgraph knows. Maybe we want to look at the mint and NFT mints also. So you just click open the NFT mints. You can leave the transfers open. And then again, just click all these bottom fields. And you see in the same transaction, 2 events were emitted, once the transfer and once the mints. But you would probably say, oh, but yeah, okay, cool. I can now have events of my contract. That's nothing new. I was able to get these also with get logs, if get logs. What is this? Doesn't help me much. That's correct. The magic in the subgraph comes when we start to look at how it is built. Now we just had a boilerplate. We didn't look at any code, and it's already very good and helpful. We have a GraphQL interface to query our contracts events. But what we want to do is we start to extend that subgraph in a way that it provides all the data that we need in that order as we want to organize that data. So let's go over to the subgraph code.
We are first on subgraph YAML, right?
Exactly. Subgraph YAML is the manifest. It defines the subgraph. It says like, where does it run? We see on line 7, it's Celo Alfajores. We see the name of the contract that we gave before. Also the contract address on line 9, the start block on line 11. These are all the information that we typed into the CLI. If you scroll a little bit further down, then you see on line 22, the ABIs are referenced. So the ABI was copied over from Hardhat over to the subgraph. Yes, we see it on the right. And then later on, we just see event handlers. So the graph basically starts with event handlers. The event handlers triggers so-called mappings. We can look at the mappings later on. And if you scroll a little bit more up, then we also see on line 3, there is a schema. And let's open up the schema GraphQL for a second. In the schema, you can think about the database table definition. We have entities, and each of them is then in a table, and each of that table will then be transformed in the queries as we saw before on that Explorer. It's important to know that despite the schema is named .graphql, that's not the GraphQL schema that is published from the graph node, from the indexer. That GraphQL schema defines the database. All right, so we see that the schema.graphql contains for each event an entity. We always store ID as bytes. The owner, again, as bytes, is an address behind the scene. Block number as big integers, and block timestamp the same, and transaction hash. So each of these entities have like some standard information and the ones that you have in the event. Now, if you go into source mappings, now we see the mappings, and the mappings are very simple functions if you want. Like these functions, as we see on line 16, are triggered whenever the graph node sees approval event. And then all it does here is just line 17, it creates a new approval entity. You can think about a new row in the approval table. On line 18, we see the ID. So it's actually the transaction hash of the event concatenated together with the log index of the event. Because you could have like the same type of event multiple times in the same transaction. That's why. But that's boilerplate. We don't need to think about. On line 20, we start to assign fields of that new entity according to the parameters that the event emitted. So in an approval, we have an owner, an approved, and a token ID. And then on line 24 to 26, we have the standard fields like block number, block timestamp, and transaction hash. They are just cool to have for events, so we can filter and sort and that kind of stuff. And on line 28, we save. The cool thing is this is assembly script. It looks very similar to TypeScript. In that view now, VS Code doesn't even know the difference. So everybody that understands TypeScript should feel at home with assembly script. So Nestor, I know that you said like you want to do a little bit more here, right? Can you explain what you want to do?
Yeah, I was thinking about updating the current schema we have to use three types: token, token metadata, and user. Why? Because I want to show folks the power of file data sources and how can we now replace the use of IPFS cat for this new feature, decoupling what is stored on the smart contract and other sources.
That's a great idea. Yeah, that's a good thing. Like file data sources just recently launched in beta across Subgraph Studio and also decentralized network, but we can already use that. So let's have a look. Yes,
Awesome.
These two types make totally sense for me. So we have a token and the metadata. We have it separated, and we can start to fill them. Yes.
So let's go first with token entity. Given it's an NFT, it makes sense to have an ID, token URI, when the token has been updated, and an owner. This one will get the data from the smart contract, but we need another entity that gets the information from IPFS, right? And which are going to be the attributes? Well, the ones that we define on our metadata. If you want to check them out, go to the hardhat metadata JSON folder. And finally, the user entity that will keep a record of tokens owned by user.
Perfect. That's perfect. So one thing to note is the file data sources, they cannot write into the same entities as the blockchain data sources if you want, because the data on IPFS has not the same security guarantees as data on the blockchain, right? So that's why we need to separate those. That's why we have a token and a token metadata. But it's also an advantage because we can then start to combine those two, but we will see that. That's perfect. So when we have the schema ready and we change the schema, the next step is always to run graph code gen again. What CodeGen does is it takes the schema and creates the boilerplate code out of that schema. And that's what we use to write them. That's what we need to write the mappings.
Got it. So graph CodeGen.
Perfect, yes. And if you now open the mappings, again, source Celo box, you will see when you scroll up between line and 13 some errors because these entities do not exist in the schema anymore.
Let's fix this by replacing them with token metadata, and user.
Perfect. And then we can delete all the other mappings for now.
Okay, we have a new blank canvas. What is the next step?
Yeah, I would now write the transfer event handler, but I think we already have one prepared.
That is correct. I have already handled transfer. As you can see, here we need the IPFS hash. Let's add it, and if you're curious about where I'm getting it, let's check the base URI from the smart contract.
Exactly, but I see on line 26 that there is a missing import. The data source template needs to be added to the subgraph manifest first. Open the subgraph.yaml.
Okay.
And then here we need to add the data source template.
Okay, so first, let's remove the event handlers we won't be using anymore, right?
Exactly.
Then we will add a new template for token metadata of kind file IPFS, and we're gonna map it with the entity token metadata.
Exactly. Here we make the distinction. The file data sources, they do not have access on other entities. Like it's very important that there is a separation of deterministic and secure data from the blockchain and indeterministic data from IPFS or other file data sources in the future.
And finally, we need to let the template know where the ABI resides.
Perfect.
Anything else?
The ABI actually is currently a workaround because the file data source by itself does not necessarily need to have an ABI, but for some compatibility reasons, we still need to add it. Got it. Cool. Now we can check if we did everything right by running graph CodeGen. Nice. Well done, Nestor. From top of your head, perfect subgraph definition writing.
Thanks, I appreciate it. What if we now go back to the mapping?
Yes.
And now in the mapping, we can finally import token metadata template. Now we need to add handle metadata, right?
Exactly.
Could you share what is the difference between both handle transfer and handle metadata?
Sure. So the handle transfer is triggered when we see a transfer event on Celo or Celo Alpha Cores. And what happens here on line 20 is similar to before. We can go into the event, but this time we do not just store the event, but we create a token or we try to load a token. So here's the trick. So first we go to our database and see, do we already have that token? Because if I minted the token, send it to you, and then you send it back to me, these are two transfers, but they're all concerning the same token. So we don't need to run the code between line 21 and 30 again, because that's actually also a little bit slow code, but it's okay to run it once. So that's the trick here. So we check, do we know that token already? And line 21. If not, we create the token as we saw before with the events. And on line 29, here actually the magic happens. On 29, the one that didn't import before, here we tell the graph node to say like, hey, actually now here's an IPFS URL and I want you to retrieve that file from IPFS. And as soon as you retrieve that file, please call the handle metadata on line 43.
I see we're missing some imports. Let me add them.
Thank you. Cool. Let's see. Nice. So what happens is now the graph node was able to retrieve that file on IPFS and now runs the handle metadata handler with the bytes and the content. So in the bytes, we see actually the raw bytes of the content that was downloaded from IPFS. And then we need to just do whatever we do with bytes that we want to get into a JSON. So on line 46, we actually load now that token metadata. That's also referenced if you scroll a little bit more up. Yeah, here on line 28, if you open schema and you scroll up, then you see on line 5, we defined IPFS URI is of type token metadata. So on the database level, here we define a relationship between those two entities. And it's actually a one-to-one relationship. One token has also always one token metadata. And if you go back to the Celo box, to the mappings, then we see that we set on line 28, we actually set the foreign key on token to the token IPFS hash. And on line 30, we instruct GraphNode to download that token IPFS hash. And if you scroll further down, on line 46, in data source.string param, the exact same string is there. It's something like IPFS QM blah 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 /1.json, something like that. It's stored there on the database. And with that trick, we can link the relationship. So that's the key. On token, we set the foreign key to the IPFS hash. And then on token metadata, we set the ID as the same IPFS hash. And that's how GraphNode and GraphQL then later on can create this beautiful relationship. On line 47, that's classical parsing. We just parse the raw bytes with a JSON parser and convert it to object. And then on line 48, we check if that actually happened or if that didn't work. But if it happened, then we have now a JSON object that we can access. And the rest is more or less clear. We just go through all these attributes that we saw before in the JSON file itself, store it on the entity. And finally, on line 79, we save. That's beautiful. Well done.
So yeah, if I'm correct, here we can be completely creative of what we can do with assembly script, right?
You're correct. Assembly script is like a completely Turing complete language. You can do whatever you want. Like some people do, I don't know, Merkle root proofs with assembly script. Some people wrote a synthesizer in assembly script. You can do generative art, or you can like only your imagination is our limit.
That's great. Now that we have modified our mapping, what are the next steps to update our subgraph?
Perfect. So the next step after is always locally try to build the subgraph. So you write command graph build. That tries to write the assembly script or to compile the assembly script on the local machine. Now it's perfect. Flawless code that just works out of the box. And then the next command again is like graph deploy. You probably have it in package.json. You can also just run yarn deploy. It's the same as we can copy paste over from the studio. Now we need to increase the version number to 1.0.1 something. Whatever your version schema is. If you want to really go down into the rabbit hole here, then we should say, because we are changing the API, we should increase the major. So you're probably right.
Good point. Yeah, let's go with 2.
Cool. Now I'm curious. Is it able to retrieve the file from IPFS?
So am I.
Let's
go to the Explorer. What do we need to see?
So now instead of transfers, we see tokens. And I would just query for tokens. And you see where we had IPFS URI, there is another arrow. That means we can, with GraphQL, because it's a graph, we can traverse that graph. And because a token has a token metadata, we can now traverse in. So I would say from token, we take ID and no further below, token URI. And then from IPFS URI, I would say all the fields. Please click also ID. Yeah, ID also and description. Let's see. I'm very curious what happens here. Did not work yet.
Guess what? I know, another bug. We figured out that we were wrong about how we were getting data from the JSON object on the handle metadata function. Why? Because we were addressing attributes as an object and not as an array. So we fixed it and it worked like charm.
Boom. We got it. Nice.
It's working.
Amazing. See, and now we have a subgraph that caches data from IPFS in the decentralized graph network if we would deploy it to the or publish it to the network. And yeah, and can query that from the front end. Next edition will be building a front end on top of a GraphQL API.
Simon, thank you so much for such an excellent coding session. I learned a lot, and I hope everyone who watches the video too. Do you want to share any final words for developers building on Celo and how they can ask further questions?
Yeah, sure. I love Celo, such a great chain. It's one of those ecosystems that you really feel that they are here for the values. So I'm more than happy to work with whoever wants to build on top of Celo Alfajores. Feel free to come to the Graph Discord. We have people there happy to help. And yeah, can't wait to see what you're building.
Thanks again, Simon. Have a great day.
Bye, Nestor. Thank you.